Good afternoon, everyone. Good afternoon, students.
Good afternoon, sir.
What is strength today, Mithun?
25, sir. 25, sir.
Come fast, guys. It's already 12. Right? So in the previous class, we discussed about analysis of prestressed concrete members towards flexure, right? So today we are going to discuss analysis of same prestressed concrete elements towards shear. Okay. So why? Because as a structural element should be sustainable towards failures, isn't it? So beam should have a strength towards shear and bending. So then only your beam will be under, serviceable condition at the same time. So it itself resembles that your beam is designed under limit state of collapse. Okay. See, whenever you start you should design member towards resistance of its failures. Okay. So normally beams will fail under shear. So by that you have to design your member towards shear strength. Beams will fail under bending. So by that you have to design your member towards bending strength. Okay. So in that way. But here, the criticalness of designing your beam or designing your prestressed element towards shear is very important. Why? Because designing member towards shear is very critical. So why? Because you can't, imagine the shear failure. Why? Because there is no much shear reinforcements provided in your beam. Okay, in your prestressing element. Okay, in that way, it is very cumbersome to design your element towards shear. Okay, so to make your member sustainable towards the shear. So usually, if you take any beam, okay, so the member will fail under shear and then it goes under bending. Okay, so the shear failure is the first one. So when the beam is having resistance towards shear, obviously, so it will have tendency to show its strength towards bending. Okay. So that is how things happen. So let me share you the presentation on analysis of prestressed concrete beams towards shear. Okay, right. Okay. Okay. So let's talk about here analysis of beams under shear. So here the analysis of reinforced concrete or even the prestressed concrete members for shear is more difficult. Why? Because here for analyzing these members, there are few methods which are going to be adopted. Like methods means in the form of a principles of mechanism. So here we are going to compare with the analysis of axial load or flexure. See, when we are talking about analyzing member towards shear, so we have to compare that with analysis of member towards axial load, even with the flexure. So comparing with the axial load and flexure, the designing or analyzing the member towards shear is very tough. Okay. So in that way, here the analysis for axial load and flexure are based on the different principles. So what are those principles? First one is equilibrium of internal and external forces, which we already discussed in analysis of prestressed concrete beams towards flexure. Next one is compatibility of strains in concrete and steel. And the third one is consecutive relationships of materials. Okay. So in that way, these are the three principles of mechanisms which are going to be used to analyze member which is subjected to direct loads and member which is subjected to bending. Okay. So comparatively with these axial load or flexure, designing or analyzing the member towards shear is very tough. Okay. So in that way, the conventional analysis for shear is based on the equilibrium of forces by a simple equation. Why? Because I think in your strength of materials, you already solved many problems based on the equilibrium conditions. How? Summation of V is equal to 0. All vertical forces is equal to 0, which gives you to analyze a particular numbers in terms of shear. How can you define the shear force? What do you mean shear force? Summation of vertical force is equal to 0 is not a definition of a shear force. Okay. The definition of shear force is nothing but internal resistance of a beam at any cross section towards an external load. That is what a shear force. Okay. So the internal resistance of a beam at any cross section within the length, okay, of any cross section of the beam towards an external force. That force, either it may be a concentrated load or UDL load or varying load, whatever it is. Okay. So here, based on the equilibrium conditions or based on the equilibrium of vertical forces, so the conventional analysis is going to be used to analyze the structure or to analyze the members towards shear. Here, the compatibility of strains is not going to be considered. Why? Because here there is no point of strain. So why? Because there is no direct stresses. There is no point of strains to be considered. By that, the compatibility of strains are which we are considering it as a 0. And coming to the third mechanism, which is the principle of mechanism, which is the consecutive relationships of materials. Here, relating stress and strains of the materials and concrete or steel are not going to be used. Okay. So that means for analyzing axial members and flexural members, you need any one of these three mechanisms. Okay. Equilibrium, compatibility, and consecutive. But analyzing a member towards a shear, compatibility and consecutive relationships of materials are nowhere be useful. Okay. So only equilibrium of internal forces due to the external forces are only can be used to analyze your member under shear. Understand? Okay. So this is what principle of mechanism to analyze your members towards the shear force. And coming to its strength, so the strength of each material corresponds to its ultimate strength. Exactly. So why? Because the member which we are going to be used, it's a composite member. Okay. So the composite member will have its own ultimate strength. Okay. So the material what we are going to use to make it as a composite, it's a steel and concrete. The ultimate strength of those materials will use its strength towards shear. Okay. So by that, the strength of concrete under shear, although based on the test results is empirically normal. Okay. So in nature, you can able to understand the shear results, okay, uh, based on its empirical equation, okay, empirical equilibrium equation. So what do you mean by shear stresses? Okay, we are discussing here. So what is this? So shear stresses generates in beams due to bending or twisting. So I think in your strength of materials, you already did one test called torsion, right? See, in torsion, what mechanical property you are going to calculate? So which is shear modulus, isn't it? So when a member is subject to twist, the member will have shear in its circumference. Okay. So by that, shear stresses always generates when beam bends or when beam twists. Okay. So these are the two types of shear stresses which are called a flexural stress or a torsional shear stress. Okay. So based on its behavior. Understand? Very, very important, Amma. So you have to keep it, I mean, you have to mark it as a very important point. Shear stresses always generates in beam due to bending or twisting. Without this, there is no possibility of shear stress generates in a structural element. Okay. So based on the bending, there will be a bending shear stresses takes place. Based on the twisting, there will be twisting or torsional shear stresses takes place. Okay. Because twisting is a behavior, bending is a behavior. Due to bending, flexural shear stress. Due to twisting, torsional shear stress generates in a beam. Here, so that is what you need to understand. So let's talk about stresses in an uncracked beam. Okay, because without cracks only we have to analyze the beam, isn't it? So let's talk about stresses in an uncracked beam. Right? Yeah. So the following figure shows the variation of shear and moment along the span of a simply supported beam under a uniformly distributed load. So the variations of normal stress and shear stress along the depth of the section of the beam as shown in figure. ANT figure. Let's see the picture. The picture observed here. There is a rectangular beam of width B and depth H. Okay. The longitudinal beam which is subjected to uniformly distributed load. Okay. So at bottom most you can see the shear force diagram and bending moment diagram. I think you all know how to draw the shear force and bending moment diagram for a simply supported beam subjected to UDL load. So what are the stress diagrams for this? The first one is normal stress. What do you mean normal stress? Normal stress and direct stress and okay. Right? So this stress resembles its bending behavior. This stress is a shear stress diagram. Correct? For this rectangular beam, this is the bending stress diagram and this is the shear stress diagram. Bending stress and the flexural. This is the shear stress diagram. At neutral axis, at CGC, your bending stress is 0 and the normal stress is 0 and the shear stress is maximum. At outmost fibers, your bending stress is maximum where the shear stress is 0, right? So this gives the variation of forces and stresses in a simply supported beam. Clear? So based on this, one should understand the general loading conditions and the shear force and moment vary along the length. Clear? So why? Because bending stress and shear stresses always vary along the length, right? So here the normal stress and shear stress vary along the length as well as the depth. Why? Because as your depth increases, your bending stress also will increase. As your depth increases, your shear stress will decrease. Okay. So why? Because bending stress and shear stress is inversely proportional. They are not directly proportional. Okay. They are inversely proportional. So that's the reason why your normal stress and shear stresses varies along the length and even along the depth of the member also, right? So in this case, the combination of normal and shear stresses generates two-dimensional stress field at a point. Very, very important. Okay. So ఇలాంటి ఒక సిచ్యువేషన్ ఏమవుతుందంటే, so due to the combination of these two stresses, one is the normal stress which is due to the direct load, other one is shear stress which is due to the lateral force. Okay, so the two-dimensional stress field will develop at that particular instant, or at a particular point. So by that, at any point in the beam, so the state of two-dimensional stresses, which are going to be expressed in terms of principal stresses. Okay, na? So why? Because in your strength of materials, we discussed about the what do you mean principal stresses? Simple stresses to principal stresses to difference, isn't it? What are the simple stresses? Simple stresses are the one where your force is perpendicular to the axis of the member or perpendicular to the plane of the section. Okay, na? And what do you mean principal stresses? Principal stresses are the one where your force will be with some oblique, okay, with some obliquity, with some angle. That means your force is not directly proportional to the, which is not perpendicular to the axis of the section. It will be with some inclined force. So this inclined force can be resolved into two forces. One is a normal force, other one is a tangential force. Avuna? Clear? Andana? So in the principal stresses, one should understand force won't be perpendicular. Force will be with some incline, okay, making an angle of theta or phi with respect to the plane of the section, right? So at that point, there is a possibility of two forces developed. One is the direct force, which develops direct stress. Other one is the tangential force, which develops what? Shear stress. అర్థమవుతుందా? ఇక్కడ రెండు స్ట్రెసెస్ డెవలప్ అవుతున్నాయి అట్ ది సేమ్ క్రాస్ సెక్షన్ అంటే అది సింపుల్ స్ట్రెస్ అవ్వదు, అది ప్రిన్సిపల్ స్ట్రెస్ అవుతుంది. ఇన్ దాట్ ప్రిన్సిపల్ స్ట్రెస్ ఓన్లీ వన్ డైరెక్ట్ స్ట్రెస్ విచ్ మేక్స్ member having a direct stress, other one is tangential force which makes member to have a shear stress. ఎందుకంటే tangential force only makes member to shear. ఓకే, అంతే కదా. టాంజెంట్ అంటే ఏంటి? టాంజెంట్ ఆల్వేస్ యాక్ట్ ఆన్ ద సర్ఫేస్ ఆఫ్ ద మెంబర్. ఆన్ ద సర్ఫేస్ ఆఫ్ ద మెంబర్ మేక్స్ మెంబర్ టు షియర్ ఆన్. అంతే కదా. ఇప్పుడు డైరెక్ట్ ఫోర్స్ ఎలా ఉంటుందమ్మా? పర్పెండిక్యులర్ టు ద యాక్సిస్. టాంజెన్షియల్ ఫోర్స్ ఎలా ఉంటుందమ్మా? ఆన్ ద సర్ఫేస్. ఆన్ ద సర్ఫేస్ ఉంటుంది. On the surface makes member to shear. Okay, so that is the reason why in analyzing your member under shear, okay, so the two-dimensional stress systems are nothing but principal stresses. Very, very, very important. Okay, please try to note this. Principal stresses are చాలా important. Okay? Very important. Principal stress. So here, the two-dimensional stresses which are going to be expressed in terms of principal stresses. What do you mean principal stresses? Principal stresses in the sense, one is the direct stress, other one is the tangential stress. Okay, tangential stress. So here, the Mohr circle of stress is helpful to understand the state of stress. Antena? Endukante meeku principal stress instance cheppinappudu there is a two methods. One is empirical method, other one is graphical method. Kada empirical method enti? You have to derive one formula. Formulas man derive chese mean formulas gurtunda meeku sigma 1 plus sigma 2 by 2 plus sigma 1 minus sigma 2 by 2 cos theta. Kada they are all one is direct stress, other one is the shear stress or tangential stress. Tangential stress and shear stress anna okate, right? So adu oka empirical method. Inkoti enti? Graphical method. What do you mean graphical method? Graphical method means you are going to draw some more circles on a graph to analyze the member or to identify the forces which are acting on the member. Okay, so those force or stresses called direct and shear stresses. So here the Mohr circle of stress is going to be helpful to understand the state of stress. Okay, you got a చాలా important note, right? So please try to highlight that, right? So the Mohr circle of stress is helpful to understand the state of stress. So before cracking, the stress carried by steel is going to be negligible. Why? Because in composite member, steel never gets cracked. Antena? Steel eppudu crack avutunda? No, steel always expand. Steel always have an expansion. But concrete will get cracked. That's the reason why before cracking, the stresses carried by steel is going to be negligible, right? So when the principal tensile stresses exceeds the cracking stress, the concrete cracks and there is a redistribution of stresses between concrete and steel is going to be generated. Okay, so in this principal tensile stresses, when it exceeds the cracking stress, and when it exceeds the elastic limit, cracking stress and it is crossing beyond its elastic point. Okay, so when it exceeds the cracking stress, the concrete going to get cracked, and there is a redistribution of stresses between concrete and steel is going to be generated. Right? Understand? So that is what happens in in a composite member when it is subjected to loads. Okay. So for a point on the neutral axis, let us take an element 1. The shear stress is maximum and the normal stress is 0. Antena? So the principal stresses is inclined at 45 degrees to the neutral axis. So the following figure shows the state of in-plane stresses. Manaki ardhamavuthundi. Okay. So I think the picture was not shown here. So I think you can able to compare this with the principal stresses and strains which we discussed in the second year of strength of materials. Okay. So why? Because you all know the maximum principal stresses will occur at an angle of 45 degrees to the perpendicular plane. Okay. So the principal stress is inclined at 45 degrees to the neutral axis. So by that the shear stress is maximum and where the normal stress is going to be 0. Okay, so that is how you are going to analyze your member under shear in terms of principal stresses by drawing more circle diagrams. Okay, so here the next concept is how to calculate the shear. Calculation of shear demand. Ela calculate chestar shear forces or shear stresses ni ela calculate chestar. So the objective of designing is to provide ultimate resistance for shear. Avuna ante. See, when a member is subjected to shear, it will have a shear cracks. Mara shear cracks mana avoid cheyali ante what I have to do? I have to design member to control shear cracks. Okay, by that member should have an ultimate resistance for shear. Member ki shear resistance undali. Then only it can able to control the shear cracks. It can able to control the shear forces. Okay, so the main objective of analyzing this members, pre-stressing members towards the shear is to provide ultimate resistance for shear. That is VUR under V and the shear, U and the ultimate resistance, which is greater than the shear demand under ultimate loads. Ante kada ultimate loads ni resist chese member ki emunnattu ultimate resistance unnattu. Okay, so that is the reason why VUR is always greater than VU. So manam design of steel structures kuda manam chestunnam. When we design your bolt under shear, what is the statement? What is the condition over there? Design strength should always be greater than or equal to applied strength. Kada applied force. Kada design strength eppudu actual strength or applied strength or applied force kanna ekku undali. Okay, so that is what the statement. Here also the same. Ultimate resistance for shear should always be greater than or equal to the ultimate loads. Okay, so let us take a simply supported pre-stressed beam. The maximum shear near the support is given by the beam theory. Okay, ఎందుకంటే మీ అందరికి తెలుసుండాలి, when you designed RCC you should all know in a simply supported beam when it is subjected to load, at center there will be a maximum bending moment, at support there will be a maximum shear force. So that is the reason why more stirrups with less spacing will be provided at supports. Okay, more dia with more number of main reinforcement will be provided at center. Why? Because at center bending moment will be more. By that main reinforcement can able to carry the bending stresses. At support shear forces will be more. By that more reinforcement will be provided at supports in terms of stirrups to control the shear forces. Okay, so I think you all know that. Even at center also there will be stirrups, there will be shear reinforcement, but they will be with the long more in space, ఎక్కువ space తో ఉంటాయి. ఇందుకు at center towards center shear force will be very less, almost zero at center. Center లో shear stress అనేది zero ఉంటుంది, shear force zero ఉంటుంది. That's the reason why towards the center your spacing of the stirrups will be more. Towards support your spacing of the stirrups will be less, and more stirrups will be provided. Okay. So here the objective to design ultimate resistance should be greater than the ultimate loads. Okay. So let's see the picture. I think this we already studied in IS 456-2000. So which gives the clear idea about understanding the behavior of a beam under shear. Understand? Right. So let's talk about the design of stirrups. What is the purpose of the stirrups? How you are going to design your stirrups? ఇవన్నీ మీరు ఆర్సీసీలోనే చదువుంటారు. IS 456-2000, it is clearly given the design of stirrups is always based on the reaction at supports, which is going to be introduces compression at the end of the beam. Okay, beam end lo compression jarugutundi kabatti there is a possibility of more shear forces or shear stresses develops at support. Okay, so the critical section can be calculated with the distance effective depth from the face of the support. ఒకసారి మీకు పిక్చర్ చూపిస్తాను, by that you can able to understand. So let's see the picture over here. This is a simply supported beam. So at mid span, half of the length will have more in space stirrups. Why? Because at the mid span, your shear forces or shear stresses will be very less. But towards support, your shear forces will be more. By that, the stirrups which we are providing in a beam should be having less in space. L/4 distance at both supports will be provided with less spaces. So this is a typical variation of spacing of stirrups which provide in simply supported beam. If you take cantilever beam, even in the cantilever beam also, at support you will have a maximum bending moment. At support you will have a maximum shear force. By that, in cantilever beam, towards support there will be more stirrups with less in space. At free end there will be stirrups but more in space. Okay, so you have to understand that, right? So I think the notations you all know. dp is nothing but depth of center of gravity of steel from the extreme compression fiber. ds is the depth of centroid of non-twisted steel, right? So by that, the center of gravity of steel is at a higher location near the support. The effective depth will be equal to ds. Okay, so commonly to vary the spacing of stirrups along the span, other sections may be selected for design. Usually, the following scheme is selected for beams under uniform load. Okay, so what are these? The two statements are given very clearly. Close spacing for quarter of the span adjacent to the support. Wide spacing for half of the span at the middle, right? So these are the two statements given clearly to understand better, okay, to in designing your stirrups for a beam. For large beams, more variation of very important statement amazing. For large beams, more variation of spacing may be selected. The following sketch shows the typical variation of spacing of stirrups for the span L. Okay, for the span L, right? So this is what designing of the stirrups. And next one is designing of the transverse reinforcement. Okay, so what do you mean? What is the difference between shear and transverse? Both are same. Okay, shear and transverse are okay. Because if you take a longitudinal beam, there will be two kind of forces acts on a beam. One is longitudinal bending, other one is transverse failure. Longitudinal will make your beam to fail under deflection. Transverse makes your member to fail under shear. So that is the reason why to control your beam under shear failure, you have to provide your beam with transverse reinforcements. Okay, so transverse reinforcements under we have to provide stirrups to in terms of a transverse reinforcement. Okay. So when the stirrups should say stirrups will be with less in width and more in depth. Okay. So that is how designing of transverse reinforcements will be take place, right? So we will discuss this designing of transverse reinforcements clearly in the next class. Why? Because all these formulas which you already studied in your RCC will be followed here as well. Okay, ఇక్కడ కూడా మనం అవే follow అవుతాం, right? So in the next class we will discuss about designing of the transverse reinforcements and the designing of the stirrups for flanges. Why? Because in your prestressed concrete elements, your beams never be only rectangle. Your beams will be in a form of an I shape, T shape, angular shape, C shape, low type. Unnappudu, how you are going to provide your reinforcement, shear reinforcement for the flanges? How you are going to provide shear reinforcement to the web, and this is chala important. Okay, so that all we will discuss in the next class. Why? Because all forces, even in the flanges and the web, will be in a form of a transfer, will be in a form of a tangential motion లో ఉంటాయి. Okay, చూడండి మీరు చూడొచ్చు ఇక్కడ ఫోర్స్ కూడా ఎలా ఉంది. The force is not acting on the plane, it is acting, sorry, it is not acting perpendicular to the plane, it is acting on the plane. Okay, on the plane always makes member to shear off, makes member to distort, makes member to slide. Okay, understand? So this is what exactly about the shear stresses in planes due to the shear lag effect. Okay, okay, so this all we will discuss, because here shear center, shear stresses, all these concepts will come into picture. Okay, so this we will discuss in the next class. So the topics which we discussed today are: one, what are the principles of mechanisms to design, to analyze axial and flexural forces, out of which for analyzing your shear stresses, we are going to use only a conventional analysis for shear, which is based on the equilibrium conditions. Okay, adi manam discuss chesam avuna, right? And the next one, what are the stresses in a uncracked beam? Uncracked beam lo stresses ఏ విధంగా ఉంటాయి, and what are the uh, how you are going to calculate the shear demand. Okay, shear demand అనేది ఏ బేస్ మీద క్యాలిక్యులేట్ చేస్తారు, and how the stirrups are going to be provided in the beam. Beam లో మనం stirrups ఏ విధంగా ప్రొవైడ్ చేస్తాం, right? So these concepts which we discussed today, right? So yeah, so only 5 minutes left, I mean sorry, 7 minutes left. Any doubts you can ask me related to this topics, guys. Any doubts? Right, guys, any doubts? Guys, any doubts? No doubts, ma'am? No doubts, right? Okay, so tomorrow we'll try to continue. Possibly tomorrow we will have a quiz on third module. Okay, so because we have done quizzes on the first and second module, so we will try to put quiz on third module. Okay, so మన lecture already అయిపోయింది కాబట్టి analysis of lecture మీద tomorrow there will be a quiz. Okay, so please prepare well. Tomorrow once class starts, I will try to share a quiz link to you. So by that we can conduct the quiz effectively. Okay, so please prepare for that. And yesterday I have shared you the notes also from first module to third module first part. Okay, so in a word file got a share chesanu, it was there in your WhatsApp group. Please try to have a printout of the notes which gives whole information and a few problems on pre-stressing losses and introduction to pre-stressing also, right? So prepare avandi, there will be a quiz on analysis of pre-stressed concrete towards lecture. Okay, then see you tomorrow, guys.